Hello everyone. So today we are going to implement the remove last method in our singly linked list. So the pattern is same. First we will do the coding and then after that we will come back and then we will execute the some values. And again that is going to return us a value or maybe null. Okay. So as you guys remember, we discussed in implementation of array list and also other methods. Every time when you are going to implement any new method, always think, are you able to reuse the previous implementations of these methods? So now we can see. So first thing is always, okay, if is it empty or not. So I can say if is empty, then it means there is no value, return null. Okay, first edge case is complete. And I can also achieve the same thing by doing maybe head, if that is null, return null. So both are same, any which you like. Okay, next, if I have a list in which we have only one value, how I can figure it out? It's a one value. There are two ways. One is I can say if the value is size equal to 1, and in that case what we want to do, I can reuse. So basically if there is only one value, it means it's a remove first, like there is only one value and I can reuse the remove first method because in the end it's the same thing. So this is done. So here I achieved the kind of a reusability, plus it will save us some bugs. And here again it depends how you want to test. So size equal to 1 is okay. Head dot next node equal to null. This is again a one check which can give us 100% surety there is only one value. Then I think so if we do head equal to tail, it means again we have a one value, because if, yeah, there is a possibility head null is equal to null, but in that case if head is null it will return null. So all are like you can use anyone because it's an internal implementation, no one ever use. So in my case, uh, I'm going to choose maybe, okay, this one is also okay. And so what's next? Now it's time to think about how to implement. So basically remove last means we need to remove the tail, which means if we are going to remove the tail, I need a previous node from the tail. How we can achieve? As you know, we need to write a while loop which is going to take kind of a to trace until tail. And as we have a tail, I will say like kind of like this, while uh, variable current is equal to head. And then what I will do, I will say current a current next node equal to tail. It means currently uh, uh, basically not equal to null. It means I need to do current is equal to current's next node. And if you look into this, you can easily see it means this loop will break when current dot next node equal to tail, which means the previous node from the tail. And after that what I need to do, I can easily do something like current uh, or value is equal to tail dot value, and I need to return value. And tail should not be here null, but it's okay. Okay, so then I need to do, okay, tail you are equal to current. So now what I did, I gave tail to the previous one, and then I will say next node should be null, which is before that is tail. So in this case, what will happen, we achieve what we want. And the most important thing, the buggy thing, size minus minus. So basically, if you see in this case, remove first, I will return, and in the remove first will take care of the size. But after that, our algorithm is implemented here, so we need to take care of the size minus minus. Okay, but there is a duplication of code. Like you guys remember, we wrote a get not method, so I think we can use this one. This one is also doing kind of a same thing, so why not use this one? Okay, so if I want to use that one, then what I will do, I will say, mm, this condition should be removed. Then I will say, okay, value node previous tail, any name which you really like, get node. And what will happen here is I'm expecting the last one, size minus one. So basically, as you know, the index, this is index 0, but size always start from 1. Like size is 1 means index 0. So in that case, size minus minus, and then after that I need to ask the second last one. So in this case, get node will give me the second last, and then after that, what we need to do, we need to do only the sys node and node, and everything looks good now. And this one, we can remove this, because okay. So in this case, before going to run one timer, head not equal to null, it means it's empty, or I can use is empty then return null. Then I'm using if head is equal to tail, it's mean I have only one value. Then remove first is the same thing. After that, I'm saying, okay, now I'm taking care of size minus one. What I need to do, take a node, the second last node, and then after that take the tail value, then update the tail, and then return the value. Now we will try to run, and then we will say is our implementation is working or not. So we have a list. In this case, first we will see what is this list. So in this case, basically the list is 1 2 10 3. Now we will try to remove last. So now it removed 3. So I think it's working. So basically 1 2 10 3. Then after that we remove 3, and then the remaining is 10. Now I can try again. So in this case, 10 will be removed. Yes, and now remaining we have 1 2. In this case, 1 2 will be removed. Yes, and now remaining we have only one value. So now last case, when I will run this, basically this is going to call remove first. Yeah, it's working. After that list is null, which is good. And now after that, if I call multiple times, it is always null because we have a check, null check. Okay, so to make sure this one is calling remove first, I can put a checkpoint here. Is it this one or this one? And sorry, we can run again one more time, and then we'll see. So node 2, still we have two values. After that, this time when I will run, this should call in internally. Now we can run. So now debugger is here, going inside, checking, oh yes, remove first, now taking care of everything from here, and now good to go. So this is our remove last method. Welcome back. So first, we can create a, so I have a head, simple as that, head, and I have a tail, and I have a size. So in this case, first time I have size is equal to 0 and the client call the method list dot remove last. So in this case, what will happen? The head is null, tail, there is no need for a tail. So in the code, we will check, okay, if head is null, return null. So we are safe. So in this case, done. Now we have a size 1, it means I have a list where I have some value and my next pointer is null. So in this case, my head is pointing to this, my tail is pointing to this. So in this case, once we will call the remove class, the head equal to null is skipped because it's not null. Then we are checking the size is equal to 1, or I think we are checking head is equal to tail, but all the same. So in that case, we will see head is equal to tail. Yes. So what I'm saying try this task to the remove first method, and when it will go to the remove first, I'm not going to explain. If you I will recommend you to go and then check the remove first implementation video. So in that case, in the end, we will have nothing here, everything is null, and this will be 0. And now I think we can discuss size is equal to 2. I think 3 or maybe 4 is okay because all are same, but in case of a 4 we have more ability to see multiple cases. So in this case, I have a first node 1, then second node 2, then third node 3, and then the fourth one, which is 4, and this one is null, tail. So 0, 1, 2, 3, but the size is 4 and the head is this. So in this case, once the client is calling list to remove last, first 2 checks are skipped. 1, it's not empty, it's not null or empty. Second, it's not only a 1 value, it means now we need to think about our algorithm. So we implemented 2. First we implemented by using, I use the while and the current one, like by taking this current and then moving one by one, and then until this, and then I remove this, like tail move to this, and then I ask current equal to null, the next node equal to null. But we can discuss the other approach, which the final approach which we use. So you guys remember I asked get node method to give me the node, but in that case, first what I did the size minus because we are sure it's going to be 3. Oh yes, one thing, the most important thing we need to remember. So it's a single threaded implementation. If you have a concurrency, then this is not for you need to take care on your own through synchronize, or don't use this what you are implementing, because there will be issues, because these are not atomic operations. I'm not going in that like you change this, but later that there is a concurrency, there is a switch. But you need to remember, we implemented single threaded data structures in interviews. But it's a good question, maybe someone can ask, and maybe you can also share, so that will always give a good signal to the interviewer, okay, yes, you really know what you are doing. So this is single threaded. In case of single threaded, it's going good. So now I already removed to 3, which means I'm saying 0, 1, 2. Then you guys remember I asked get node size -1. So basically I'm interested in the second last. So in that case, what will happen? Size is 3 minus 1, 2, 0, 1, 2. So I got this as a node and this one. Once I have this, I took this tail dot value 4 into a value variable, and then in the end I return this. And then what we did okay, tail, you are going to equal to node, which means tail is going to sign like this. And then after I did node next node dot next node equal to null, which means this. I also can do tail dot next node next after changing this, but it's okay. By doing this, what this is null, nothing is here. This one is now is not attached, that there is no reference to this. It means it's ready for the garbage collection. So there will be no memory leak because there is no reference. So once the garbage collection execute, it will take care of this object and we are good to go. And we remove this. Now we can do the same thing again inside -2. So we can discuss about the size, the time complexity. So remove last in case of a singly linked list. It's always big O of n, and n is always the number of nodes or size. So yeah, so you guys remember in case of a remove first, it's always big O of one operation because we always have the first one, we only move towards that. But in case of a tail, the remove last, we need to trace because we are not able to figure it out the previous. Yeah, assume it's a doubly linked list, then it's also a big O of one operator because then in that case I have a tail also have a next node and the previous node, and then once we will implement, then we will discuss. I don't think so it's a good place to discuss. So yeah, for today's I think they anything else, yep. And yeah, so hopefully I'm able to share something new with you. So see you in the next video. Bye.